Welcome to this session where we're going to define the bullseye with multiple variations of the spelling of bullseye because I wasn't quite sure how to do it. Right, okay, well, you can have it several ways. And I just want to explain to you what the issue is through a very, very short presentation, which I hope will come up. And how do we go into presenter mode, my dear? I'll present.
Click up there.
Aha. Okay. So within IGS and both within the geosciences, which after we started broadened out to soil, water, plants, you name it, it's sort of gone viral with everyone using it. Even before it went viral, we were running into this problem of what is the minimum metadata required to describe a sample? And the arguments were always thick and fast. And I even remember in the early days, what was it, one of the meetings in San Diego where the basalt people wanted this and the meteorite people wanted that and the soil people wanted that. And to me, it was pretty obvious we weren't going to be able to achieve it. And we weren't going to be able to achieve it, in my opinion, with the technology that was available now. But with linked data, RDF, I think we've got a way out. And as you know, we got this grant from the Sloan Foundation. We were trying to explain what we were trying to do. And in a moment of frustration, I drew what, if you didn't know me, that's actually called a Leslie Graham, because I draw these a lot to try and either, this one's in circles, most of mine are in boxes. Because the Sloan Foundation was also dependent on us being able to show that we could expand to other groups, and the inevitable question was, well, you know, how are you going to do it? What's your proposal? And so what we said was that if we could define a common kernel that goes to samples of all types, then the idea is that the individual communities could then start putting their rings around it. And so I'm a geologist, please forgive me. But if you're doing rocks, okay, so you'd have a ring here, which would be lithology. And then, so if that rock was a moon sample, you'd have more specialised rings outside it. And equally as well, I came across this problem when I was in Geoscience Australia, where our marine community went nuts on developing vocabularies and started to develop vocabularies in the marine section for grain size and sediment type, when they were ones that had already been developed by the geology group under the auspices of the International Union of Geological Sciences. So you can kind of see now how with RDF coming in and which wasn't available when we started this work 15 years ago, what we're saying is that you as an individual can pick a vocabulary and use a term from something's online and pull out the URI for that term, which then by clicking on it, you get the automatic definition of that term. And so as you see over on the right, you can mix and match. But for certain communities who are working together and trying to get a coherent data set, they could actually say, well, this is our minimum metadata to describe this sample, or the samples from this collaboration, and we request that you take the terms online from X, Y, and Z. So just to show you that it's not an imagination, I don't know whether you have seen this, but this is something that has been developed in Australia, I hope. And it's a vocabulary service. And I actually work for these people one day a week, and just before Christmas, my Christmas present was, would I please try and do something about sorting out the plethora of earth science vocabularies that are around. But you can see here how I can not just look up the vocabulary, but up here I can put in a term and browse on vocabulary or concept. So if I type in LITHOGY and go search, my query returns that this concept is sitting in all of these vocabularies, and this has been set up as a proper vocabulary service. So if you go into any one of them, you'll get a URI for that vocabulary. And so going back to my original concept, either you or as a community can define that we will use the simple lithology CGI as the Commission for Geoscience Information, or maybe we'll use the geoscience one. Okay. And so if you look over here with publisher, it tells me which publisher is publishing these vocabularies. And to me, what then becomes important is that I see straight away there are two international groups. So you've got the International Union of Geological Sciences and you've got NASA. And the NASA ones are actually the GCMD. And in the Australian Research Data Commons, we have a pairing agreement with GCMD. So we're making sure that this is a properly managed replication of their vocabularies. So the concept of having access to rings that I'm going to put around the thing. Hello, Ted, what are you going on about? Oh. Okay. Okay, children, so have we settled our arguments and fights, etc.? So anyway, what I'm just saying is that we actually, so you can see, anyway, this is something that we've developed, and then when you pick your vocabulary, do you want it in binary, JSON, LD? And I don't know why this damn thing's not moving on, Sarah. Sarah, you might have to help me. But anyway, you can sort of see we've got the prototype of being able to achieve what we said we wanted to achieve with the bullseye model. So that then brings us back to what should be in that bullseye. And I was very fascinated by your talk this morning, Ted, where you said if you define mandatory elements, that's all you'll ever get back. But anyway, we live to fight another day. Sarah, how do I get back to my presentation?
You have to go up to the top, all the way up.
Yeah, I'm
and
there.
then go to tab.
Tab.
And then move back over to the presentation, which should be that.
Yep.
Yeah.
Okay. This is just a short seeding the ideas of where we're coming from. So in line also with what Ted said this morning, this is my other diagram that I've used in many presentations, and I meant to bring this up at Helsinki, Lindsay, when we were talking about the minimum metadata. And in my experience, you've got this balance between having a very rich metadata schema that doesn't reach out to many people because they can't use it. And likewise, if you've got something that reaches out to a lot of people, it could damn well be useless. And so there's kind of a sweet spot that you've got to navigate on what you're doing. And so if I go back, I guess that is what we're here for, because whether intentionally or unintentionally, IGSN is now being very widely adopted through the IGSN project. We're talking to biology community, to archaeology, to a lot of others. But first and foremost, it did come out of this community. And so if we want to go to another community, we want to get mixed up in this thing where we decide what is the minimum metadata. then we should be able to take along the perspective of the geoscience community into that. And so I guess if you can understand those two graphics and the fact that there actually is a vocabulary service that can deliver what we want, albeit it needs a bit more polish, I'll hand over to some of the research that Sarah's been doing now on other metadata schemas that are around for samples.
How is your vocabulary server comparing to DODC?
What do you mean?
Well, the British Oceanographic Data Center has a vocabulary server that's been sort of the type locality of vocabulary servers for a decade at least. I'm just curious about overlapping vocabularies.
Can I actually say, if you don't mind, I know this is an IGSN session. Yesterday I met with Doug Phils and Adam Shepherd, and I said we have an emerging problem here because some person in Australia, like we've got the timescales, you know, Paleozoic, Mesozoic, registered in the IUGS vocabularies governed by the stratigraphic, and they've put a copy of that in GCMD. And so up until now, you know, when I showed you, here they are, you pretty well could go down and pick the best one. So now what do we do? This one's by IUGS, this one's by NASA. And so, first of all, that's what I'll be trying to work on this year, is we need to get to a stage, that's what I raised, and I've actually raised it with Erin as to whether or not this is something we should have as a working group, a cluster within ESIP. This vocabulary proliferation. It's all right if it's a direct copy where you're bringing over the URIs from the original, but when someone puts another copy and creates URIs, different URIs for those terms that are already registered, we have a problem. And also, which is what's impacting IGSN, was I was at the IGSN meeting when we made the choice, or the choice was made, to go with the ODM vocabularies, when we knew the IUGS ones were around doing the same thing, and the IUGS ones had governance, sustainability and funding. So really, we've been talking about this 5-star rating of vocabularies that range from what's got the horrible name of the proverbial brain fart, where someone just types up a list and sticks it in there, as opposed to a high quality one that is governed, is in controlled namespace, multilingual and available, you know, for conversion into linked data formats, so that when you then go into that vocabulary service, the user, the non-initiated user, is going to know which one is probably the most reliable one that's going to be around in 10 years' time. Okay? But the other thing we want to do is, I think, as you all know, or those of you who are involved in setting up and maintaining vocabularies, it's a lot of money and effort. So why are we duplicating? Why am I seeing similar vocabularies? It's like happening with magnetotelluric data. Australian groups developed one, the USGS has developed one. I don't know whether that's going to end up, but, you know, what can I say? We have a procedure of being able to see. At the moment, we're checking vocabularies, but we're not checking concepts and terms within those vocabularies. And for this to move forward, which is why I think the schema.org, which is what's the pain, this is what's clashing with. Maybe the schema.org move is the way to actually have the earth science community agree that this is the authoritative vocabulary for our term. But anyway, I'm just saying this is what's going to creep into this argument, and I don't know how to solve it because I can't solve it from Australia on my own.
We just had an interesting discussion in the last session on kind of the the process of trying to bring all of those things together in the semantic harmonization
Was
part of
this
things.
with Adam?
Yep.
Yeah.
Well, Adam was in that session. It's not
Yeah,
his
I
session.
raised it
was
with
the one
Adam.
before that with Lewis and
Yeah.
Pierre Luigi and some others. And I mean, I think the ship has already sailed. I mean, there are these clearinghouses of vocabularies, like the NERC vocabularies and the thing at ANDS and whatever else. And those are useful in themselves because they at least tell us, hey, these vocabularies are out there. Maybe they give us a little bit of metadata about them to say, okay, this is maybe who's maintaining it or when it was last touched or whatever else. And we have a proliferation of those things being stood up because oftentimes the vocabularies that have been out there aren't really usable. I mean, they're there, but you can't like go interface with them and work with them yet. So somebody goes and spins it up somewhere else on a linked data server or whatever else in order to make it interoperable so you can actually go program against it and go do something against it. So I think the work now is on semantic harmonization between all of those different things. And that's happening in different communities. We looked at the Obo Foundry work that's gone on in the biomedical realm quite a bit. There's work that we need to do in the marine geosciences world where we've got a whole bunch of different terms from NERC and from some other places that all need to be aligned with each other in some way. And so, I mean, I think that that's starting to coalesce around a method to do that where individual communities like these that get together and say, hey, we want to do a bunch of work, can maybe go to some of the clearinghouses of vocabularies and say, okay, these are things that are out there. Here's places where our different data systems have actually used and referenced terms in those vocabularies in some way. Now, how do we get together and do the work, the hard work of saying, here's the actual alignment between all of these disparate things. And here are the actual, dereferenceable URIs that need to be used. And, this is the way these identifiers actually connect to each other. And then that becomes the source to start building new systems against from that point. But you're always going to have legacy systems that point off to one or the other of any of those other things that are out there that all need to be brought together.
I don't mind the legacy systems. I guess we were a bit horrified when we saw that the timescales one had been plonked into GCMD when it was already available in a reliable one and linking back to the source. So coming back to what you said, Ted, with the NERC, it's very timely you raised that because the NERC vocabularies, someone is now wanting to put them in Research Vocabularies Australia. Those vocabularies I listed, the IUGS ones, don't really overlap with the NERC ones, or they didn't when I used to have something to do with it. Something might have crept in now. But again, we would like to do it in the formal way, the way we did it with NASA, or that would be my recommendation, that we don't have some person stick an authorised vocabulary system in Research Vocabularies Australia. We do what we did with NASA. We go to NERC and we say, can we have a local copy that is, harmonised and in sync?
Yeah, I think NERC is a big one. I think Pangea also has a fairly, either Pangea, maybe Kirsten knows, either Pangea or TIB.
Pangea, yeah.
Is it Pangea? Yeah, has a big.
Based on properties in the data set.
I think so, yeah. Yeah.
Yeah, but so what I'm arguing is a lot of people are trying to get going in linked data, which is what we're trying to do with the IGSN. And so that's why we call them the brain fart vocabularies that are appearing everywhere. But with time, they're going to go. It's just a matter of fairly quickly coming up with some, firstly, guidelines to a user as to what to use, but following on from what was just said, I think we also, which is what I said to Adam and Doug, can we start actually working out some protocols on these vocabularies to try and stop people adding to the problem? But, it's sort of like the idea you had, Sky. And anyway, whether or not that can be a quick thing we do as a cluster in ESIP, or whether it's something of the semantic. But anyway, that's good because you understand the caveat of this method we've got will work, but there is an inherent problem behind it, which is the proliferation of the vocabularies. But still, provided those URIs, you're using terms from a URI and they're maintained, it won't break the system. Because that's why I'm prepared to go ahead with it, knowing that that's the problem. Okay.
Trying to find something that came up based on what you said before.
Okay.
So on the topic of these various vocabularies, I was doing a little bit of background to see, and sort of to go back to the agenda, we're going to introduce these topics, and then we wanted to ask around the room people for examples of what metadata schemas they use, and also in their institution with their work with physical samples, what are some of the required fields that they use to sort of to aggregate those things. And in doing background research for that discussion, I was looking at what schemas already exist for physical samples and other data as well, because just to get an idea of what sort of things do they require and the number of requirements. And so I'm going to just talk about that stuff very briefly before we'll get into some examples from around the room, and then we'll look at what IGSN has as different metadata fields, and then we'll sort of hopefully be able to discuss what ones might go into that kernel. So I'm sure many of you in the room have heard of Darwin Core before, but they have an extension that came out, I want to say 2017, the EFG, the extended for geosciences. And the easiest way to look at it is here's a oh man, sorry, let me change permissions on it. Sorry about that. Hopefully now the link will work. There we go. So this is, the EFG was an extension made for geoscience materials because there's an overlap between the biological and where they're coming from. And so they developed a metadata schema with a lot of rich fields that, again, might already exist in other areas. And the easiest way I found to look at it was this diagram that just shows some of the high-level categories of the metadata schemas, metadata fields that they're capturing in the schema. So we can see things like mineral, rock type, stratigraphic sections and areas. But these things are mostly, as you can see, it's suggested topics of areas that you might capture. And let's look at the schema itself. You know, I jinxed myself. I was in a session earlier where I was thinking like, oh man, look at all the technical difficulties they're having. Hopefully that won't happen to me. Okay, but as you can see, they offer just a wide variety of metadata, possible metadata terms. And this is a huge list. If we were to try to scroll through this, it's very long and not structured, and there's no required elements of like these are the minimum that you might need if you were going to describe. Yeah, I can see Ted's face for those of you online. It's a very long list. It's kind of overwhelming.
Replacing Mark is what I think of as when people say ISO is complicated. I've grown up. Librarians actually do Mark pretty well, and it's a lot more complicated. But this is now a replacement for that, I think.
That's true. And it's not to say that not all of those fields might be necessary to pull from in developing a record, but if we think about, well, when we go back to this idea, we need to develop a minimum requirement, you can see how you might look at a metadata standard like this and be overwhelmed and not know where to begin. How much detail should you get into your samples? What is too much detail, and where do you get that that balance of what Leslie was showing in that diagram, where you've made it so rich now that it's of no use to anyone because it's just so detailed.
What does ABCD stand for?
Access to biological collections data. And it's equally as rich. We can take a quick look at it. It's linked in the notes if you want to look at it.
And it now has that's the Earth extension
Yeah.
for geoscience.
Mm-hmm. But again, like I was saying, it's kind of overwhelming. There are a few other similar guide points out there. The USGS National Geologic Geophysical Data Preservation Program has a template. If it will open. Sorry, I'm not used to Macs. you can see there's a number of fields and definitions. Sorry, wrong tab. But there's also, again, it's guidance as far as you might. How do I make this bigger? There we go. There's quite a few ways that you can describe a sample, and there's lots of guidance as to what they'll accept. And I think that's wonderful to support all of this, but again, it might help to have some minimum concept of what might be required for discoverability across different fields and within the repositories that we eventually hope to ingest this material into. How do I get back? Okay. So again, I've just provided a few links here. I won't go through all of them because I do want to get more into discussion, but there's some examples. We could look at some data ones. There was, again, referring back to the session that Ted was hosting this morning. You looked at DataCite and some of the different mappings and of metadata schemas across, I forget what, there were 3 of them. Yeah. But I do think it's interesting, again, DataCite has 6 required fields, Dryad has 3, so we're looking at a very small nest of items to identify the actual object. So with that sort of badly organized background out of the way, we can either jump into looking at the current list of the IGSN, or we can go around the room and see if people want to share examples from their institutions. I'm not sure which order we'd prefer to go in.
I did put together some slides, but
Do you know how to
I
get
left
them
them
up?
upstairs.
Oh, okay.
But I mean, actually I tried. It didn't respond. But so I did not do the GCMS example, but what I did was pulled our, the metadata requirements for fossils as we currently describe them within USGS, which we went through this process with the Smithsonian, the National Museum, 2 years ago, where we aligned our metadata requirements with theirs they use EMU as their registry, and we use science-based kind of. But then we went together in this neutral space of specify to crosswalk our metadata requirements so that we could both use, both pull from the data into our systems. But what I discovered in this process was that while this was important information for the Smithsonian related to our fossil collections, from a user perspective, it's probably not all that useful in some ways. And there's a lot of proprietary information, non-standardized. While everything has been crosswalked to Darwin Core, they're not really standard metadata attributes. So it was a useful exercise for us, but maybe not so useful for downstream users.
So who is it useful then for? Is it the curators? It's the internal use, and it's part of the complete collection management, right? So is it a problem because it's too generic?
No, it just refers to a lot of USGS specific information and ways of coding things.
Oh.
And so you need to know something about how USGS describes specimens in the collection, what kinds of documents, internal documents they refer to and things like that in order to understand metadata itself.
Is it at all possible to, if the IGSN, for example, now comes up with a core bullseye metadata set to crosswalk to?
Yeah, I think so. You just lose. Sorry, I you would just lose a lot of information regarding historical knowledge and associated documents that would be useful. But, you know, could be, if we had DOIs for those documents and other ways of linking them, that would be possible too in the future. It's just, we haven't done that.
Well, the information could still be, the information could still be part of the landing page somehow. I mean, it's the extended profile then, so you still get to it.
Yeah, so when you said they were crosswalked to Darwin Core, but they weren't actually standard things, does that mean they became an extension to Darwin Core? Or?
They fit into Darwin core categories, but not, I don't know how to describe it. Like they were, they maybe used identifier, a type of identifier within Darwin core to describe a location identifier that we had that was specific to USGS.
Yeah, the big issues with a lot of those crosswalk things are that yeah, you don't really get into what is this thing, whether it's an actual identifier or some piece of text or whatever, actually mean. What does it dereference to, or what does it link to that's a meaningful thing like that? And a lot of the Darwin core standard, and we've dealt with this quite a bit, is just, I mean, it's broad enough to drive a truck through, and they basically have, you know, taken a pretty pragmatic approach along the way to say, okay, well, this is a field that you should have in your data, and you should have this kind of information into it, and here are some suggestions of the best kind of stuff to put into that are being used in these particular communities, but nobody's kind of gone down and said, okay, this is specifically what this needs to reference. And we're dealing with that in a lot of the different data sets that have been aligned with that standard, that now we have a whole bunch of information for. We have a whole bunch of records, and now we go, okay, well, we want to put these things together in meaningful ways, but we can't do it until somebody does the semantic alignment that needs to be done, you know, between all of these pieces.
I have a Darwin core comment as well. So I do physical object management for a small nature preserve in New York that's an OBFS site. And we have quite a few insect and plant specimens. And one of our concerns with Darwin core is the extension for abundance values is very difficult to pull back out. So if we have done a standardized sampling for a certain area over a certain period of time, it's hard to, it's very easy to capture occurrence, but it's very difficult to capture abundance in the Darwin core system.
Yeah, I mean, one of the other issues that's happened with Darwin core is a lot of these communities have come along and developed these extensions that should have actually been done in a way to come back to that core kernel idea that you talked about, where, you know, instead of the, you know, group going and saying, okay, well, here's the bunch of attributes that we need to have, and they all have these specific names associated with them. What do these things kind of, how would these be encoded as data more generally, with some sort of additional classification on the information that would allow us to more easily do the semantic alignment work that needs to be done? And in the Darwin core, the thing that's happened that's kind of helping to get us down the path a little bit further is the event data part of things, where you're actually recording observations and measurements with measurement types and measurement units associated with the event, not so much the occurrence of the species, and then extensions on the occurrence of the species that need to happen over time. And so, like in the OBIS case, with our OBIS data system, we've been bringing a bunch of those data online. We now have millions of records that have event data associated with them, and thousands of different individual measurement types that have been identified in there. But we now have a corpus of that stuff that we can start going through and saying, okay, what's the logical alignment between all of these different ways of calculating abundance over time that might map to each other? So we can leave the original data the way that it is, but then do the mapping work to say, for some purposes, we can pull all of these pieces together, and we actually can, you know, and we're not like trying to find it in 50 different places within the data standard. It's all sitting within one, you know, part of the model in some way. So, I mean, I like the idea here, but I think that we should try to steer toward putting more things into the core kernel and less things into those completely disparate, you know, outer rings of the system if we can.
In that context, is event an observation event? Is that what it is? Yeah, okay. Yeah.
Something that happens.
I still got it. I'm holding on to the smoking stick.
There's a
No,
mic
but,
up here.
I was just going to say that, you know, the way that ISO dealt with that, you know, without any judgment, is they have a standard way of extending the standard. So they say if you want to, if you mean, and this is sort of the heavy end of the extension. If you actually want to add something essentially to the UML model, you describe that thing in a standard way, and then so a machine can actually read the descriptions of the extensions. And I mean, this is in theory, right? I don't know anyone that, I mean, we did it at NOAA. We actually had formal descriptions of the extensions we were creating. And that's the one mechanism that might be useful. And, you know, in problems of Dublin Core or schema.org, you sort of extend it by making up a new word.
I mean, to me, this idea of including observation acts into the schema of the sample is not right. to say, to me, you know, what we're looking at here is the description of the sample. And you have that identifier of the sample, and that should link you to observations that were done on it. And I'm thinking about this in, you know, with my perception, at least, of samples being something that can be distributed, that gets, you know, where observations are made over a long time frame and in, you know, whatever number of labs and or in field sites and so on. So you don't know who is the one who enters these, you brings the events into the profile of the sample. You don't even know what events pertain to that sample. That connection, shouldn't that be done somewhere else? So I'm confused about that.
Well, I think it depends on your use case. I mean, if you're, you know, my mind is around the F and the A of FAIR for samples. And if a scientist is looking for a sample that's related to a sampling event or a place, then I think that that's essential metadata to describe that sample. And it can't be necessarily separated from the essential information about that sample if you're thinking about a discovery paradigm, I guess, in my opinion.
I mean, maybe I'm misunderstanding the event.
And also that would depend on your search algorithm.
Sorry. So we put a paper out in 2017. Daphnis DePuter was the lead author on it that kind of launched the whole thing for OBIS and what we call the OBIS E and V data for environmental data. The problem that we were trying to tackle there is somewhat along the lines of what Lindsay was saying, where we had folks that were deliberate because of the model that we were putting out to serve these data up about occurrences. Now, these aren't samples from that perspective, but it's analogous in some way. Because it is an identification of, you know, an individual fish, an individual clam, whatever it happened to be. Or in some cases, it was an identification of a school of fish observed and an estimate made of their abundance or their numbers or something like that, okay? And so we were dealing with these cases where folks were deliberately decoupling their data and providing just the occurrence, but they also had all of this other stuff that was done, all of these other measurements or observations that were made at the time when that occurrence was observed and that occurrence was recorded. And so we were losing data in the network because people had it, but we forced them into a data model where they just had to give us that one little piece. So that was one motivator for changing the data model to allow for it. I mean, I don't disagree with you. I do think that in general, there's probably a better data system to deal with all of the other stuff that was associated with the sampling event where you went out and collected the samples and pulled those together. And in some cases, those data are served up as well through some other system. But we still need something to link them. We need something that gets us to, here's the sample that was collected, the physical thing. This is all of its information about how it's being managed from this point forward, blah, 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 subsamples, everything else that goes on with it. But we still need to get back to that event that happened at a point in time with certain parameters, certain methods, all of that kind of stuff, because that's going to be critical to discovery, and that's going to be critical to downstream use of that information at the end of the day.
No, I agree, and it's to me, the purpose of the unique identifier to make that connection. So you have an observation that you will identify, and I'm specifically thinking actually back on at our IGSN workshop in Berlin. I don't know who was there. We had this interesting diagram that Ruth Durr made, where sort of different descriptions of the sample or events had their own identifiers and were linked to the sample identifier. So those would sit in their own, profile schemas, depending on what they were. In some cases, an occurrence, in some cases, maybe even the act of classifying something, which has its own source or originator, creator, and so on. They should all be linked to that one sample. So what we're talking about, I think, is really what sits with this central identifier of the sample.
That's the metadata you're talking about here. That's my whole question.
Yeah. I think that's what is the core piece, the essence of the sample. That, I think that Ruth was actually thinking even further and saying even that core needs its own identifier and be linked to the sample identifier, because there may be different people having or different places where a set of information, even that core information, is kept. So it should be identified so you can point to whatever is in KEMU versus, in EarthChem about that sample.
Yeah, I think that the, identify early and identify often is the best rule. But I think Leslie's core diagram there, in terms of a standard like ISO, that core diagram should take care of people and organizations and identifiers, and maybe process steps or quality measures of some kind, or that core should be what the ISO standards describe as sort of the generic metadata that all these things are going to have: people, citations, identifiers, location, spatial and temporal extent. Those kinds of things should be in that common kernel, so they're all describing people or citations or identifiers the same way. If we could get that common kernel adopted across these kinds of samples, I think that would be a big step. And that translates to schema.org, or probably certainly to Dublin Core as well. At the discovery level for those standard things, the crosswalks are pretty straightforward.
And I also think, if the vision of the future of IGSN or unique identifiers for samples, period, is to have, a central repository for the metadata about samples, you want that to have a certain level of richness that people are going to be able to discover things that are relevant to them. And that's all of those things that Ted said. You may want to know, a person, a historic scientist that collected, you want to know where everything that person collected is, or, yeah.
But it does come, what we already know is that, for example, the concept of location or time does not apply to every sample. So does not apply to all samples, especially when you go into material science, into synthetic materials and so on. You know, so you have, we often think within the box of natural samples and going out and collecting some creature.
There are analogs to those things. So it's either, time of creation or time of collection.
There are, yeah.
Kirsten?
There it is, yeah. No. Oh, that was the diagram that Ruth had generated.
This is the, sorry, I haven't got much voice left. The Canberra smoke was pretty, this is a diagram that Ruth sort of put up for us to, a sample, the pit core metadata, and then, all the different types of metadata that can be added to it. And you could easily have balloons going out. So nice when people are bossing me around, telling me what to do. I love it. So see, this is one of the interesting difference, well, probably analogous one to what you guys were talking about with geochemistry. It's quite common. You bring the sample in and someone does ICP-MS on it, and then goes to another lab and someone does something else on it, and someone then goes and does geophysical properties on it. And so, yeah, they're going to have different metadata around what they've done, but at its core, the sample will remain the same, could remain the same. You could take a subsample of the sample, but
Then it becomes a new sample.
it's a new sample.
Yeah, I think it's just important to remember that, every time you try to put one of these diagrams up, we inevitably describe the thing that we care about most as the center of the universe. And so suddenly that becomes like the thing that's at the center of the diagram, and we expect it to always be the center of the diagram. But I think that the reality is, especially in kind of the linked data world, is that information about samples is going to show up from lots and lots of different vectors. It's not all going to happen through any sort of a complete homogeneous system or a underlying metadata system. And so what we have to come up with is the way that any of those things that are themselves going to be the center of the universe can express that nugget of information that we care about via the IGSN registration process or something as the sample and serve out its core information, but then also have additional stuff that can be associated with that based on the context that it's coming from. So I just get nervous when I see these kinds of diagrams because they always sort of assume that we're the center of the universe and not understand that there are lots of different ways that that information needs to get expressed to the world.
Yes.
Good argument.
But I think, the purpose here is to focus on the sample, right?
In reality, I am the center
of the universe. No, I mean, what? Yeah. No, I really think that there are all kinds of pieces of information and they have their relevance, but we want to make sure that that sample, no matter where you put it on this slide, or in that context, is described in a way that, it is fair in some way. And, this has been what Lindsay was referring to in finding, making actually informed decisions on a sample based on the metadata that are available in some central catalog. This has been a big point of discussion within the IGSN organization, where, do we need that central point to search? That there has been a push for a more distributed system and saying, every allocating agent in the system just sets up a OAI PMH provider, and anybody can harvest the allocating agents that they care about. And I think that process is, we've found, not going to work very well, that we're moving more towards that central idea. And that makes this exercise now more relevant, and no matter how important all these other pieces are, we need to define what is relevant for the sample to be discoverable and accessible. So that's what I meant with, we're here for the sample.
No, I'm not disagreeing with you at all, but I think it would be useful to kind of track through some of those specific use cases around that, because I don't disagree with you. I mean, I think we absolutely need to bring together some central index of all of this kind of stuff to help promote at least interoperability from the discovery level of, how do you go about looking at all these things. But as soon as you do that, you have to make choices about what do all of these different things mean when they put this value in this particular field, and how deeply does it need to be defined in order to produce the type of interoperable interface to all of that you want to produce. So I mean, just taking the example of like searching based on the name of a person or institution, say that stuff shows up in a particular part of the metadata model, whatever the core model of this thing is. Do we care, or does the user care if it's because that person went out and physically sampled that, or because they published on that sample, or because they provided an interpretation on that sample, or because they had some other touch point on that? Do we just put all those together and say, well, it's a person's name, and so we try to blend them all together into one place? And then again, how much work do we do on the person's names to say, well, we've got Joe Smith and Joe B. Smith and Joe F. Smith. We think the F might have been a mistake, and maybe they're all the same Joe Smith, so we're going to try to think they're the same thing. Right?
In that context, we also need to remember that we're dealing with a lot of legacy data in this world, right? Where you will never find out who Joe Smith was, and he's not going to have an orchid from 1700 something. It's just reality.
The reason orchid doesn't give orchids to dead people is because they can't be responsible.
And in some of our records, is it Mrs. Joe Smith or Mr. Joe Smith?
Those geology.
Well, it was a big problem at one of the Smithsonian sites, was that a bunch of records were collected after this guy's death, but they were all collected by Mrs., but attributed through their, yeah.
So while we had this like break.
Take over again.
Yeah, I was saying, we've kind of like, gone, which is great. What Leslie's pointing at me.
And then also online people, they want to say something.
Okay. I don't know if I have how to get the GoToMeeting thing back up. Escape. Okay. Is anyone online that want to add anything before I call on the people in the room? Sorry, I minimized it so I can't. Did anyone say anything in there?
No one said.
Okay, so no one said anything online, so we'll skip that. But yeah, who wants to go first? I'll call on either Joan or Denise. Go.
Okay, so I'm at the Lawrence Berkeley Lab, and we've been trying to decide on what should be essential metadata across different sample types. So it's kind of a similar exercise, but a little bit more focused on a lot of the national lab projects that we're working with are collecting environmental samples that are then sent out for microbial analyses. So the other standard that you haven't mentioned is the minimum information about any sequence that was developed by the Genetic Standards Consortium. So we're really interested in linking the geo and bio samples in that way. So I've also started a crosswalk comparison of some of the basic collection metadata in CSAR because we're doing a pilot test of getting persistent identifiers for samples and using that to eventually link the geo and bio samples. So we have a list of metadata that is particularly relevant for the sample types we're dealing with and comparing that to a few different standards. So I don't know how useful working on something like that as a community might be for some of this essential core metadata, but I've started some of that work, so maybe that could be something to discuss further at some point.
No, I think that's great, and that's something that I've thought about from the CSAR perspective as well, of when people come to us and ask about guidance for submitting samples and how that might map to other metadata fields, especially as Kirsten and Leslie mentioned, we're getting a lot more interest from people with water samples, biosamples, and things where it's not an exact map to our terms. And I think it might be useful to either to find out what you've been doing, if you don't mind sharing it, and maybe we could have some more conversations in that regard as well. No,
give us that because there's quite I just realized that we have quite a long list of callers who are participating remotely, and it would be
could we get those of you who are online to, if you look at the schedule for ESIP, there's a link to these notes that we've been referring to on, if you could add yourself as attendees, maybe in a space at the top, and then we'll add those people who are in the room as well, so we can capture that. But if you want to go ahead, Denise.
Sure. I think most people in the room know who I am, Denise Hills, Geologic Survey of Alabama. I don't know who's online, so that's why I'm doing the full introduction. This idea of minimum metadata is fabulous, but I would really love it if the people that I work with were actually amenable to it. Excuse me, sorry. They all have their own ideas as to what that actually is and what format it should be in. And as Kirsten mentioned earlier, most of what we are actually dealing with is legacy data, often with people who are deceased, and we have handwriting. And so translating some of this. So when we're looking at legacy data in particular, I think sometimes we need to be aware that we can aspire even to that minimum, but sometimes something is better than nothing, even if you don't have that absolute minimum. But for the stuff that we use, it's like a location, but the format of that location, like Lindsay said, it's like it might be in a different format. We have PLSS for the majority of our older cores, and they've never been resurveyed. There's been no need. So the idea of minimum is really great, and it's great to aspire to, but you also need to make sure that you have some flexibility when you're dealing with legacy data. So that's my main point, I guess.
Sorry, just trying to capture that really quickly. Okay, so one of the things, so far it looks like we haven't had anyone raise their hand in the chat to speak from the online group. But one of the things that it's felt like came up, and I'm trying to, sorry, Macs like throw me off entirely. I know. Yeah, everything that I try, and my first computer was a Mac. I've just moved away from it. So in the discussions, some of the themes of the types of metadata that were coming up as far as important, and also where there was sort of debate upon it, was this idea of administrative metadata. So getting to, I guess, like who created the record, when was the record created, and those things are not about the sample, but are about the information captured about the sample. Then there was also the question about location and about how for a physical sample in the earth sciences, maybe that is something that you know and you can get to, but it might not be the same importance for, or might not be viewed in the same way in the biological fields. talking about it going more to the occurrence of seeing a fish or a school of fish, maybe at a location, maybe not. That wasn't clear, but I think, but that's something to question what we mean by location and if that should maybe be required in the kernel. And then also this concept of it being, getting back to what I was just saying, it being this sample or an event on a sample, and if maybe that should be its own related sphere that is going back to that diagram that we got from Ruth, where there's going to be lots of dots with lots of spheres around them that connect to other dots with lots of spheres around them. But do we want to get into maybe listing what some of we think these core metadata fields might be that would go into the kernel coming from our perspectives? Leslie, did you want to say something first?
We've been through this a few times over the years. Location, we decided not to make a mandatory element for a couple of reasons. Certainly, getting my fill with thermodynamics, we were dealing with synthetic samples. And the other thing too is location can be caught up in people not wanting it to be exposed because it's a rare fossil locality. And the other one, which I dearly love, is when you get to museum people, they tend to feel that location is the location of where the sample actually is now, not the location it was collected from. So several years ago, we started to say, no, location, much and all as I hate it, is not a mandatory field. Oh, sorry, it's a field that can be held. I'm sorry, I'm going to be mother here. Sky was before you, young Ted.
So I think it would be useful to distinguish between the ideas of core here and mandatory minimum, those kinds of things. And yeah, because I think we're talking about different things. I mean, to me, if you're going to define the core model for the metadata that needs to come in the system, the idea is to describe the parameters around which, if you're going to provide this information, this is how you need to do it, and this is how it should be done. And leave the discussion of, for certain use cases or for certain instances, these are the things that must be provided in this particular way. And I would suggest that core concepts in the metadata of space and time absolutely need to be there. And you need to work on dealing with all of the different dimensions of what those mean, no pun intended. Because yeah, there are locations that are associated with the sampling event and where something was actually picked up off the ground or out of the ocean or whatever it happened to be. There are locations with where it is now. There are location issues of, the original location can't be shared, but what we're sharing with you is some sort of fuzzy location that we've actually derived and put into the data, and this is the method whereby we went and did that. All of those different things need to be figured out for the concept of location, which is going to result in lots of different fields in your model in terms of the actual properties that need to be in there. And the same thing is there with time and with different parts of that need to be there. People, organizations, yeah, there are a bunch of these core concepts that really are core to any metadata model, regardless of where it's coming from, that need to be part of this core. And then you can deal with the issue of mandatory minimums and all that other kind of stuff.
Yeah, I agree with Sky. Yeah, I think one of the nice things that happened in ISO, and this was 2003, so it's been around for a while, was the integration of temporal and spatial extent into one thing. And so if Leslie wants to argue that there's data sets that don't have a location, that's fine. But I think what's more important is that there are things that have multiple locations. And in the early days of FGDC, the concept was we were making metadata for this map, and it had one spatial extent and one time that it was relevant for. And the transition from one spatial extent and one temporal extent to an extent that has time and space in the same fundamental core object, I think was a really major change.
So are you advocating is that part of that being part of the core, the concept of extent?
Well, I mean, I might even advocate, if I was opinionated, that we just think about ISO as at this point as a core for the fundamental stuff: people, organizations, citations, identifiers, extents is another one, really.
Remember a meeting
Yeah, so do I.
in your old office.
Oh, I don't remember that one.
This is way, way back when,
Oh, no, I didn't say minimum, I just said components.
so anyway, we did try at some point to translate ISO or to map ISO metadata to IGSN metadata, and it did not go well.
That's fine. What I said is that if we go back to Leslie's first diagram, what I said is, I think considering ISO for sort of that big core, for just the stuff that ISO agrees on. And, that we use over and over again. I'm not saying that ISO will be complete. The other important thing about ISO, and Lindsay and I were talking about this, I guess it was last week, is it has a lot of mechanisms for extending it. And that's true of O&M as well. So the metadata standards that I would argue that we should consider for the foundation are all extendable in many ways. And that's where this, when someone, a scientist or whatever Kirsten is now, stands up and says, well, this doesn't work for my data. You say, I know that it doesn't work for your data, but we can extend it to cover the vocabularies or the entries that your data needs. And we can do that extension in a standard way. So I like your diagram, but I would put the core as a layer across the bottom. And then, extensions that also have, in your diagram, none of your circles actually overlap with each other, but in fact, they actually do in the real world. So you want interactions between all of those different things. And we can do that in completely standard ways.
Well, now that you've thrown a grenade into the diagram, do we still want to go through though this, looking at what might be in this core or kernel, or
I mean, maybe we can turn it around and look at what, we had in past workshops long ago, we had in some way defined a core, but not the vocabularies, obviously.
So is that, what on page 3?
oh, sorry.
And I mean, I guess Ted has ISO fully engraved in his brain, so he could just say, check, 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 in some way.
So that's actually a good point. We might want to then, so this is a list of the metadata fields in the IGSN schema. So are you suggesting, Leslie, that we go through this list, or?
Well, no, I just wanted you to give the history of what it is. Is this the list you're talking about, Kirsten?
Yeah, I mean, this is the schema. It's not just, right?
But these are not the required elements.
Right.
It's everything.
It's everything. There's only 3
Oh, this is-
required.
Yeah, no, then it's a different list. I mean, let me just see if I can actually find the old slide. It dates back to the 2011 workshop at the San Diego Supercomputing Center.
2011?
Yeah, February 2011.
My life was empty.
Yeah, because I think this is from 2015 or 16,
Yeah, that one's
this
newer.
version.
I mean, the original one that we came up with was shorter than that.
It had, I can just, I mean, it had the sample name, obviously, and the identifier. It had the location. It had material. It, It had the collector and collection method. Not much else, right? I think age was part of it, because I thought age was considered to be an observation that is made by somebody and not part of the core. That's kind of what I'm, and well, we had sample type, and this is, one of the difficult, I think, items. I was looking with Leslie last night, right? We looked at some list of sample types from, was it the USGS? Oh, Geoscience Australia, and it has the weirdest type of samples on it. And that's one of the things I think we will need to focus on after we decided that sample type is actually part of the core. Who defines what types of samples there are, because there will be an endless number of.
Our approach, I think, is going to be define samples at the highest,
Is it a core? Is it?
No, higher than that.
That's material. That's material. So that was, I mean, you somehow material and collection method defines a lot, but what do you do about thin sections? Or I remember that the ocean drilling program database had a whole list of sample types that were like square, full round, half round, and all these type of physical descriptions. So that might not necessarily be part of it, but yes, material is clearly has to be part of the core.
I think I found, do you mean, was this the workshop in LA in 2015? Is that what you're looking for?
No, that was sort of the connection to the bio people.
Okay.
I think in terms of specifying the core metadata model, again, it's more about, especially in those areas where you're identifying things based on vocabularies. Those are mutable things that are going to evolve over time, both in terms of their contents and their definitions and everything that's there. The important part in the core metadata process is to say, these are the parts of the model that need to refer to vocabularies and need to refer to structured sources. And this is the way that you need to do that. You need to specify something that is actually resolvable so that we can go from a link to get to something. And it needs to be within this range of vocabulary types. And we would prefer that the vocabularies be managed by a governance process so that there's actually established authorities behind defining what's in them and all of that other kind of stuff that needs to go on. So it's more, not the details of what goes into the content, but the parameters around the elements in the model. So I'd say material type and sample type and those kinds of things fall into that category.
That's kind of the way we've been trying to go for some time, but we do get stuck with, like we're, ARDC has established an IGSN minting service for the academics. I'm going nuts with it because, they want a list of words. We give them a list of what rock types, which the IUGs. Oh, there's too many. We can't, And like for this, they actually want to have a list of rock types that's accessible from it because they don't understand, link the basic elements of linked data or of vocabularies. And so now what's also happening is some of them are setting up their own vocabularies. So yeah, anyway, that's just an aside. But so where are we at? Oh,
That was what we did in 2011.
so are we going to agree to that or take it out or what?
Yeah, we've got about 10 minutes left. Yeah.
Can we try to take?
Yeah.
No, wait, Kirsten, I can just make it. Okay.
Can you? Oh, okay.
Where'd it? Max.
time to get glasses, Sky, like the rest of us have had to.
I'm talking, that was Ted. No, that was Sky.
So can you,
Okay, apologies, I shouldn't have said that.
what could you say, how would you compare that with ISO? What,
IGSN is an identifier, right?
is the identity?
Yeah. Registrant is a responsible party with a responsibility of registering. Metadata timestamp in the, there's, in ISO, there are a number of different kinds of dates. So that could be a creation date, it could be a revision date, it could be, a number of different kinds of dates. So that would be a date type. Title, I think we could probably squeeze that in. Description would be an abstract. A location and time would be a sampling extent. That would
So
be
this-
one object.
This is not, I just want to remind everybody, it's not the age of the sample, it's the date on which the sample was created.
That's fine. In that case, it would be a process. I consider sampling to be a process step. And so that would be an extent associated with a process step, where that process step was done and when. Right. Yeah, well, and I agree with Kirsten that dating something is actually a process step. And I think it has the same constraints that you mentioned for the location. If you're inferring something or determining something experimentally, then it has uncertainties associated with it. Yeah. So distributor, originator are easy. Specimen type, that's a code list. So this is what Sky was just saying, that you need connection points in your metadata model where vocabularies plug in. And each one of those has a location for the code list and the URI for the element from the code
So
list.
I actually forgot that, so we do have.
Yeah, there's a vocabulary somewhere for that.
Both
Material class.
and specimen type.
And sampling method is the same thing. That's a code list for process step of sampling. So, I mean, this is, and timestamp is the same up there, and local
Yeah,
sample.
local is beyond the core, right? That's clearly, that has more detail, whatever you want to put in. This is what we're really talking about right now.
Yeah, I mean, one of the things that the curation history, I mean, actually in FGDC, back in the day, CSD, GM, and ISO, processing steps and curation histories were just a linked list of steps of certain kinds. So curation history and processing history could be the same. They both look like lineage. And yeah, so I don't think there's much. There's not much here.
Where does that leave us if we say, okay, we can use ISO as our framework? We still need to define which is, it's a subset of ISO, obviously, that defines the core.
Right.
And parameters around what you do within what you do within the implementation of that standard as applied to this overall community that are important. And I mean, there may be some aspects of what you consider to be all of the additional stuff in the local CSAR node there that might be important to address in your documentation of what the core is. So, I mean, if there are related resources associated with that sample, how should somebody go about encoding those so that they're meaningful and useful when we try to slurp all of this stuff up together into one index? Not just leave them open as, put anything in here and we don't care. But if you're going to supply this information, these are the parameters around which you should do that. But I mean, structurally, I think the ISO standard has everything in it necessary to do that. It's just a matter of providing, domain-specific guidance on how to do it, and the vocabularies that have been identified over time as important to it.
Basically, what we should be doing now.
What we should be doing now is take this core, map sort of the ISO components to the individual items, and then send it out to representatives of different communities and say, is that working for you? What would be your profile that you need?
I've started doing that and mapped what I could to ISO. Some of ISO is still a little confusing to me because I'm new to this, but yeah, and I sent it to him and he started looking at it a little bit.
I was
Yeah.
busy preparing for this meeting. So last night was a little slow. But yeah, I mean,
Yeah.
what I would tend to do in this situation is get a collection of CSAR records and write a transform that transforms them to ISO, and then use this thing that I made up called translation proofing. Say these are the things that get transformed and these are the things that don't, because what we really, so that gives us a quantitative measure with an empirical database of real metadata that's evolved over the years. And then you know what you're missing. Because, if people look at two things, then they say, well, or they say, well, it's hard. But we can do that in a quantitative way, which, drives that translation creation process until you've got 100% of the stuff.
Yeah, I mean, you do have most of the elements of what would be needed behind that translator here. And the interesting thing to do then would be to say, once you've written the translator, go get a bunch of samples, so to speak, of a bunch of these records and say, what happens when we actually pull these into what we think is the core. And then you'll find some weirdness with actual values that people have put in those fields and go, oh, wait a minute, they just didn't implement this correctly.
That's what I mean by having the empirical. There's a table and a figure that looks like this, and then there's a couple thousand metadata records. And I like the couple thousand metadata records myself because they, in a lot of the more robust standards like ISO or EML, there's a lot of elements in those that aren't used very much. And this is small enough that probably most of this stuff gets used.
It sounds like there might be someone online who has a comment. Looks like a comment in the chat is, would the ISO concept of hierarchical data help address the sample derived from other sample requirements?
It could be. Who asked that question?
Jeff Campbell?
Oh.
Am I muted? Or is anyone hearing me?
The answer is yes. Pardon? Yeah, I can hear you, Jeff. There's a couple different things in the hierarchy of ISO metadata. There's the scope code, which tells you the scope that the metadata applies to, but then the parent, the relationship that you're talking about is a little bit more like a parent relationship.
Parent, yeah.
It's like is part of or has parts, rather than expressing that in the hierarchy of the ISO metadata itself. I think it would be expressed as a relationship between two identifiers, two sample identifiers.
But in a sense, the derived sample would inherit a lot of the information from the original sample.
Yes.
Yes, it could.
It could.
But yeah.
Yeah, I think
one place, like, talking to stuff that Lindsay's been thinking about, if you have a collection of samples and then you have samples that are in that collection, those two things could be related more like a parent and a child metadata record.
No. It's more the sample.
Related metadata. There could be overlapping metadata.
Yeah, like this, the samples are in the same location as the collection that they're part of.
Right.
Yes, but the properties that are defined here what is obviously common is the location, and the collector and date. And so, though, when you take a subsample, you also want to capture who did the subsampling, right? So you start to having something different, and the material class can be different. You can have a rock, and the subsample you take is a mineral, right? So.
So I meant that a collection of rocks in a museum has a record which is a collection level metadata record. and the samples are related to that in a way which is different than subsamples of a sample.
So we're actually at time.
We are.
Kind of was, yeah, sort of an amazing pause point that we reached something within time. Anyone have any closing thoughts then before we wrap up for the day?
Good discussion.
So
I've got the microphone, young man.
You too need to find it.
Ted, would it be possible for you, it would be great if you could take that box top level Caesar, you know how you just stood there verbally and said, oh yeah, that's that, that's that, that's that. Can you?
Joan has done that.
Oh, okay, Joan's got the spreadsheet.
But it's not complete with all of this because I didn't.
No, this is actually incredibly useful because again, you're going to have samples that need to show up. You're going to have samples that need to show up in this network if we want to bring together one big index that are going to start out as Darwin core records. You're going to have a whole bunch of them. Yeah, okay, so it's not,
Is it
yeah, but this is the
here?
starting point. That's all I'm saying. Let's not go do something different. Let's build it in this spreadsheet. Yeah.
That's Joan's.
Joan, have you shared that?
It's linked above the IGSN kernel
Yeah.
on page 3, I think.
Not what happened.
Yeah, I'll clean up the notes later.
But
Yeah, this is wonderful. I'm relieved I didn't start doing this myself.
Yeah, and they're,
Still recover from that UCS.
That was the one with
Thank God Steve isn't in here or else. Oh, is he?
Do you want to for other people?
Oh my God, that dinner. So when you brought up that was the workshop with the famous dinner.
Oh, no, we're not going to talk about, yeah. No, the other bit, when Sky and Lindsay started talking about bringing in measurements, because remember part of that meeting was Ted and Simon Cox arguing about O&M versus one night. Remember a fair bit of that? Yeah, right, okay.
All right, well, thank you to everyone online and also in the room. This has been a great discussion and I'll clean up the notes a bit because they were jumping around a bit, but this I think went really well. And I'm glad that we made this connection between the work Joan's been doing and what Ted brought up to ISO. I was just praising you and you're over there chatting and not listening. So I'm not going to repeat it. But yeah, I would say thank you very much to this work that Joan has done as well to share with us. I think it will be a very good next step. Mm-hmm.
Reminder to put your takeaways in the takeaway file for the breakouts and the sessions, which is available on the info page of the schedule.
Okay. Thank you, everyone.
Well, thanks. Yeah, absolutely. This was